So now that we kind of discovered with that first example, what you guys are going to look at is that this formula of the sum of an infinite geometric series. You guys did a finite geometric series, now you're doing infinite. So make sure that you have both of them written down and you don't confuse the two. So the sum of an infinite geometric series with your first term, a of 1, and your common ratio, that's your growth rate, we get this equation. So your first term over 1 minus your rate. However, there's a stipulation that r has to be, the absolute value of r has to be less than 1, okay? So that means you're looking at all the values between -1 and 1, okay? That's where you are stuck. If you see that, that's a negative fraction, so it's going to get smaller and smaller and smaller, or it's going to cap out around 1-ish. However, if your r value is greater than 1, or your absolute value of your r value is greater than 1, then the series has no sum, okay? We call that an infinite. It's basically approaching infinity, so it's just going to keep getting added on. So you're going to need to see both types. So if I had, so this goes from 1 to infinity of 3 times 1/4 to the n minus 1. And that's 1/4, and that right there is that rate that is less than 1. So you're going to use this formula of s equals a of 1 is 3 over 1 minus 1/4, and that is 3 over 3/4, and you get 12 over 3. So just make sure you guys are seeing that when that rate is less than 1, that's when we're using this. Now if I give you another example and your rate was 3, 4, 5, 6, whatever, anything over 1, it's going to have no sum, or it's going to be infinity, you can call that.